So when we look at problems 1 through 6, are there any that we want to look at particularly? Or any one of those in particular you want to take out, or look at, or see done? So when we look at these first 6, well, we're wanting to determine the degree of the following I cannot talk. Determine the degree of the following monomials. So we look at number 1, we have 16x squared y to the third. So what would the degree be? 5, because we're adding all the variables exponents together. So that'd be 2 and 3, which would give us 5. How about number 2? So we have 5, 1, and 3. Well, 5 and 1 is 6, and 3 gives us 9. How about number 3? Are there any variables? No. I mean, we could add them all in, but they would all have exponents of 0, because anything to the 0 power is 1. Anything to the 0 power is 1. Now, the only really, I think y'all, knowing that, can get 4 and 5 pretty easily. What about number 5, 4 and 6? Well, it has 9 squared, yes? Well, what is 9 squared? Well, it's 81, isn't it? Are there any variables? So the degree is 0.
On any of these like that, if there's no variables,
This is 0. I threw that one in there just to see if y'all would catch that. Because it'd be very tempting to see exponents and count them up. But because it's 9 squared, well, 9 squared is just 9 times 9. We don't have any variables there. So the degree is still 0. Any questions on these here? Okay. 7 through 10, write the polynomial in standard form, then determine the degree, leading coefficient, and classify it by its terms. So 7, 8, 9, 10, is there one of those in particular that y'all want to look at that's looks more challenging than the others? For 7 through 10. We can just look at 7 if you guys don't have a preference. So when I look at this here, so standard form is always biggest exponent, so variable with the biggest exponent goes first, and then second going down, we decrease. So which term has the biggest, or has the variable with the biggest exponent? To the third. So it will go first. So we have negative 6x to the third. Do we have a variable with it? Okay, so we have this here. Now we don't have an x squared, but we do have an x, yes? So it would be what? And then? Welcome. So you'll need your review sheet. So we have this here. So we went from big term with the biggest exponent going down. And if there is a sign in front of if it's negative in front of one of the terms, it goes with it. Now the degree is going to be what? 3. Because when we have terms being added or subtracted, we're looking for the term with the biggest exponent. That would be the degree. Now we didn't cover any of these and they won't be on the test, but if we did have multiple variables in there, we would add those together like we do with each monomial. So the degree of each monomial is the exponents of the variables added together. And when we have multiple added together, it's whichever one has the biggest. Does that make sense? Yeah, but it does. We don't get too deep into that. On the test, if you want to do like the notation I'm writing here, D3, I'll understand what that means. Leading coefficient is negative 6, is the number in front of the variable with the biggest exponent. Since the biggest exponent is x to the third, our leading coefficient would be negative 6. You're welcome. Now, the only other thing we need is to classify it by its terms. Well, how many terms do we have? So this would be a try. 2 is binomial. Binomial is 2, trinomial is 3, monomial is 1. So is there any other questions on this one here? Do we want to look at number 8 or 9 or 10? We can look at number 10. So we have 6c minus 17c squared. So which variable has the biggest exponent? It would be the negative 17c squared. So we would put it first to write it in standard form. And our other term would be plus 6c. Because now it's in standard form, yes? Now the degree for this here would be 2. Leading coefficient would be, and our type would be binomial. Now, I don't think I put any on the test that are like, well, for the standard form that are in the form like number 9, because is number 9 in standard form? Yeah, it's already in standard form to begin with. But if we did have one, you can either rewrite it, essentially, or you can just say it's already in standard form. So if it's already in standard form, we can just rewrite it back out. It doesn't change. But since we started this one already, let's go on and finish it. The degree would be leading coefficient. Because the leading coefficient is always the number in front of the variable with the biggest exponent. So if there's not a number written, it's always understood to be 1. So the leading coefficient in degree will never include variables. It's always going to be numbers. And this here would be a binomial. Any other questions on these here so far? Okay. Perform the following operations. So we'll look at one with addition, one with subtraction, one with each of the different types of multiplication. We'll look at number 11. Number 12 I threw in there just because. But if we look at number 11, if we wrote this out, well, because it's addition, we can just drop the parentheses. And then we can combine like terms. Now, you don't have to do this next step. I just do it because it's kind of nice and easy to see. Is I'm going to reorient them so that the like terms are next to each other with their signs. And rewrite it like this here. You don't have to do this. If you can see from this equation here that 3x squared plus x squared is the same as kind of this here.
If you put, what I did is I put plus 10 minus 6, but that's the thing.
Yeah, because negative 6 plus 10 is the same as 10 minus 10 minus 6, yes. Because really, what I'm trying to see is, so can we add these together? So 3 plus 1 is 4, and we have our x squared. X plus 4. And then, it's 4. Because if you know that none of the signs for this second set of parentheses is going to change, and you can just jump straight to there, fine. I mean,
When I did number 12, I thought I was funny after answers. And at first, when I got the answer, I was like, wait, I feel like this is too much. I checked it.
Yeah, it's kind of funny. I threw it in there just to see if y'all would catch it, in that between these two here, there are no like terms. So really, we're just relisting it out in standard form as x to the fifth plus x to the fourth plus 3x cubed plus 7x squared plus 5x plus 6, because nothing combined, so it doesn't, we just ended up relisting it back out. I didn't put one of those like there on the test because that is, there's not much to it. Do we want to look at another addition? Which one? 14. So we look at 14. So 14 would not be addition, it would be subtraction. Now, we can look at it as we're subtracting it. We could go 3a squared minus 2a squared and go that way. Or, I can, when I drop the parentheses, we would get 8 plus 3a squared, because there's a positive in front of that set of parentheses, so it's not changing the sign. Now, because there's a negative in front of the second set of parentheses, we're essentially multiplying everything through by negative 1. So our negative and negative a would become plus a. Because it's changing everything inside that second set of parentheses. Now, we could go on and do our subtraction. If you can see that, go on and do that. That we can combine the a squareds, the a's, and the constant terms. I'm going to go on and just rewrite it so we can see it a little bit easier. Because 3a squared and negative 2a squared, they're like terms, so I'm going to put them next to each other. Plus a, well, there's no other common or like terms with a. And then we have plus 8 minus 9. Well, 3a squared. Since we're subtracting it, the negative and negative made a. Yep. So we end up getting plus a, and 8 minus 9 would be negative 1. Any questions on this one here? Let's look at 15. So to look at 15, since I'm going to go on and drop the parentheses and apply the sign, so it's a little bit easier to look at and a little bit easier for us to keep track of. So we still have negative 12t squared minus 5t plus 7. But since we're subtracting this second set of parentheses, the signs inside of it need to change. So our negative 4t squared would become plus 4t squared. Our positive 3t would become negative 3t. And our negative 1 would become plus 1. Now again, like I said before, if you can combine the like terms here, go on and do it. You don't have to rewrite them out next to each other. We can say negative 12t squared plus 4t squared minus 5t minus 3t plus 7 plus 1. Well, negative 12t squared plus 4t squared, or well, negative 12 plus 4 would give us negative 8t squared almost. Because negative 5 minus 3 would give us negative 8 plus 8. 7 plus 1. Yep. That's why sometimes I like rewriting it this way so I can keep track. Even as long as I've been doing this with higher degree, here it's not too bad, but when they start getting bigger and longer, I like rewriting it so that I can keep track of terms and making sure I got them all. Because it's very easy to lose them, especially once you get past 6, you get to 12, 14 terms, it's hard to keep track of everything.
You know, I've been sneezing so much today, someone is talking trash to me. Ears burning.
Ears burning, yeah. Good one. Old wives' tales. Let's look at these here. Let's look at multiplication. So 17, 18, I know, are 2. 19, 20, or 19, yeah, 19 and 20. 17, 18, 19, or 20. Is there one of those in particular we want to look at? Okay. Because the reason I sectioned those 4 off is all of these are going to work about the same, just the numbers are going to look a little different. So when we do this here, we're going to start off by multiplying the first term through. So we're going to have n times n squared. And n times n squared would be n cubed. Because I have one of them and I'm multiplying them by 2 more, so I have a total of 3. Then we'll do n times positive 2n, which will be plus 2n squared. Any questions on this, sir? Then we do the same thing with positive 3. Well, 3 times n squared would be plus 3n squared. And 3 times 2n would be plus 6n, because 3 times 2 would give us 6. Now, do we have any like terms? Yes. N cubed does not have any like terms, but our n squareds plus 6n. And that there would be our solution. Any questions on this? Yeah. Do we want to see another one of these binomial multiplications?
What's that?
So binomial.
Which is this?
Wow.
Yeah. So this binomial is 2 terms. So we have 2 binomials. So do we want to look at 18, 19? One of those there? Because we're multiplying it out. We can look at 22. Because 22 is a binomial being multiplied by a trinomial. 2-term multiplied by a 3-term. So we can go on and multiply these through. So we're going to have 6 terms total before we simplify down and combine like terms. So we'll do 2x times x squared, which would be 2x cubed, because x times x squared would be x cubed, and 2 times 1 is 2. Now we'll do 2x times negative 3x. Well, we know for sure it's going to be negative. Positive and negative and make it negative. 2 times 3 would give us 6, and x times x would be x squared. And lastly, 2x times 4 would be plus 8x. I gave myself enough room, but I don't think so. Any questions on this so far? Well, we're going to do the same thing with positive 3. Well, 3 times x squared is going to be plus 3x squared. 3 times negative 3x. 3 times negative 3 would be negative 9. And our x, and lastly, 3 times 4 is going to be plus 12. Any questions on this so far? Well, at this point here, we can group our like terms together. Now, 2x cubed doesn't have any like terms, but our x squareds do. Negative 6x squared plus 3x squared would give us 8x minus 9x would give us negative x. plus 12 because our constant terms, our terms without variables, they don't have any other like terms with it. And it's always going to really work out when we have these multiplications, the first terms that we multiply and the last terms that we multiply are not going to have any like terms. So our 2x times x squared is normally going to be by itself. 3 times 4 is going to be by itself. Normally, anyways. There could be cases where it doesn't work out that way. Any questions on any of this here so far? Do we want to look at 23 or 24? I want to look at either one of these here. 24. Now it says 5x minus 5 squared. But whenever we square something, we're saying that we're multiplying it by its self. So really what we have is 5x minus 5 times 5x minus 5. We have to rewrite it back out. So for both of these here, when they're squared, we're saying that it's multiplied by itself. And then we can do the same steps that we've done before. So we'd have 5x times 5x. Right? Our 5 times 5 would give us 25. X times x would give us x squared. So 5x times 5x would be 25x squared. Now 5x times negative 5, well 5 times negative 5 is 25, and we would still have our x. Now that we've finished with the first term, we can move on to the next term, negative 5. Well, negative 5 times 5x would be negative 25x. And negative 5 times negative 5, plus 25. So we have negative 25x squared minus 50x plus 25. Any questions on this here? So I think the real trick to this one here is remembering that 5x minus 5 squared is the same as 5x minus 5 times 5x minus 5, multiplying it by itself. So you need to be really careful because it's very tempting, and it is something that we do see, me and Miss Kendall see a lot, is students wanting to just do 5x times itself and negative 5 times itself. So we can't just square the first term and square the second. We need to multiply it by itself, because if we don't, we won't get that middle term, that negative 50x. Any questions on this here? We can look at either one of these here, and they're going to give us the same result. Do we want to look at 25 or 26? Cody, what do you think? Which one looks harder? 26? Because we're dealing with x and y. So I'm going to move it a little bit to the center. So we're going to multiply these together. When we do this, it's going to be the same as the ones we've just been doing. We're going to take it one term at a time. Now 2x times 2x. Well, 2 times 2 is 4. And x times x would be x squared. Now 2x times negative 9y, well 2 times negative 9 would be negative 18. And x times y would be x y. Any questions on this so far? Any questions on anything we've done so far? Okay. Now we're going to do the same thing with 9y. Well, 9 times 2 is going to be plus 18. Y times x is going to be the same as x times y. I'm just going to put them in alphabetical order, which would be xy. And lastly, 9 times negative 9 is going to be negative 81. Y times y is y squared. Yeah, I think it's up to 12. I've got most of my perfect squares memorized, so I can pull them out a little bit faster. But any questions on this here so far? So we're good with at least getting here? So if we combine like terms, well, the only like terms is the negative 18xy and 18xy. Well, negative 18 plus 18 is 0. Yes? 18 minus 18 is 0. So these here cancel out, leaving us with 4x squared minus 81 y squared. And this here has a special name. This is called the difference of perfect squares. 4x squared minus 81y squared is the difference of perfect squares. They call it difference because we are subtracting difference. 4x squared, well, 4 is a perfect squared. It's 2 times 2x is x times x, so it's a perfect square. 81y squared, well, 81 is 9 times 9. Y is y times y, it's something times itself. So we call it the difference of two perfect squares. Two terms that are perfect squares, something times themselves. Or it can be written as something times themselves. Questions on this here? And I think these here were some of the ones that y'all liked the most.
Can you do number 29?
29 and 31. Yes. So 29 and 31, yes. So 29, so b minus 9 squared. Well, whenever we have that set of parentheses squared, we know that it is being multiplied by itself. So what we have is b minus 9 times b minus 9 is equal to 0. Whenever we have more than one thing multiplied together to equal 0, it means one of them has to be 0. So we have b minus 9 is equal to, or b minus 9 is equal to. So on the first one here, we can add 9 to both sides, and we get b is equal to, I can do it over here, and I get b is equal to 9. So we got two answers, but how many unique answers did we get? One, because they're the same thing, b equals 9 in both cases, so we only have one answer, it's 9. And I think that's what the answer key said, it was just b equals 9. I don't think I put it down twice. So even if we do have multiple, you can go on and circle both of them. That's fine, I'm not going to mark it wrong because you have two answers and they're the same thing. I'll take it there because it is b equals 9 and b equals 9. That is the answer. It just works out that they're the same. Any other questions on 29? Do we want to look at 30? We feel comfortable with 30? I'll go on and look at it since we do have time. Because I have three things multiplied together equals 0, well, one of them must be 0. So we can set all three of them equal to 0. Now the first one's not too bad. Here we can Add 7 to both sides and get x is equal to 7. And then we would divide both by 3. Now here, 4 does not divide into 3 evenly, so I'll leave it there. You don't have to write it as a decimal because that'd be a little difficult. It'd be negative 1.3 repeated. So we can leave it as this here. And we would do a similar thing for the last one. We would subtract 3 from both sides. And again, you can leave that as a fraction. The decimal is a little bit easier to write because it would just be negative 1.5. We would get 3 answers for this one here. So are there any questions on how we got any one of these 3 here? So the next one we wanted to look at was 31. 6n squared minus 15n. Now this time we don't have two things multiplied together to equal 0. So we need to make it that way by using greatest common factor. Now if you notice on the review sheet, I didn't put a section for greatest common factor like we did on the homework, but that's because we're using it here. So I'm looking for the biggest number that will go into both 6 and 15. 2. Well, 3, because 2 will go into 6, but 2 will not go into 15 evenly. But 3 will go into 6 and 15. So we factor it out. Is there anything else we can factor out? Because there is an n in common in both. So the biggest thing I can take out of both terms is 3n. And I divide it out. Well, 6 divided by 3 is, and it's left inside. N squared divided by n is minus. Because we didn't pull a negative out, the sign would stay the same, as well as with the first term. We would do 15 divided by 3. And n divided by n factors out completely. Any questions on how we got to this point here? Now do I have two things multiplied together to equal 0? So we can set them equal to 0. So we have 3n is equal to n2n minus 5 is equal to, well, 3 times n equals 0. What does n have to be? 0. If we have two things multiplied together to equal 0, one of them has to be, well, 3 can't be 0, it is 3, so n has to be 0. The other way we can go about it is we can divide both sides by 3, and it'll tell me n is 0, because 0 divided by 3 is 0. All right, let's look at the other one, 2n minus 5. First thing we would do is add 5 to both sides. And this will tell us that 2n is equal to the last two, 33 and 34.
Yeah.
Mm-hmm. So are we good with this here before we move on to the next one? 33 and 34 are essentially the same thing. The direction I move things would be different. And what I mean by this is I want to try to keep whatever term is squared positive. I want to try to keep that positive. So when I look at 33, I need this equal to 0, and I'm trying to keep the squared term positive. Well, since it's already positive, I'm going to leave it alone, and I want to move the 28r over to it. And the way I can do that is by what? 28r to both sides, because these will simplify out and become 0 is equal to 4r squared plus 28r. So once we move everything to the same side, we're doing the same thing we did on the last problem. So what is the biggest number that will go into both 4 and 28? 4. Because 4 times 1 is 4, and 4 times 7 is 28. And what about our variable? Just r. Well, 4 divided by 4 is 1. R squared divided by r is r. So we can just write r. You can write 1r, that's fine. Or r by itself is also fine. Plus 28 divided by 4 is, and r divided by r is 1. It simplifies out completely. Because if we wanted to write that in, it would just be 7 times 1, which would just be 7. Now at this point here, we do have two things multiplied together to equal 0. So one of them must be 0. So 4 times r equals 0, well, we know r is 0, because that one's nice. We like that one. And for our other one, we would subtract 7 from both sides, telling us r is equal to -7. Any other questions on this one here? So are we good with both of these here? So the only thing we do have left is the bonus type of problem. We want to look at that.
Can we do it first?
You can do it on your own. There is the answer in the back. So what I will say is so it's what we've been doing with 2 and 2 or 2 and 3, but this time we have 3 and 3. So we would multiply there first. Here a second, and lastly we would do this here. So we're going to end up multiplying all the way through with all 3. So it's not that it's overly complicated or more difficult than what we've been doing with the 2 and 2 or the 2 and 3. It's just we have to do more of them. Because I know we didn't specifically go over a 3 and 3 in class.
I have a question.
Yes.
If you do that 2x squared times, say, that becomes
So the 2 times 8 would be,
16.
and the x squared times x would be x to the, and we'd have that there. So since we do have time, I'll go on and start this. If the bell does ring before I finish this, that's fine. If y'all want to stick around and finish it, see how it finishes, that's fine. If you have to go to the bus, you can go on and go. I'm going to upload this because I upload all these videos, so if you want to see the end of it, it will be posted. So if we look at the first one, 2x squared times 4x squared, well, 2 times 4 would give us 8. X squared times x squared, well, 2 and 2 gives us, we'd have 8x to the 4. Now 2x squared times negative 8x, well, it's going to be negative So 2 times negative 8 would be negative 16. Our x times x squared, or x squared times x, would give us x to the third, x cubed. And lastly, 2x squared times 9. Well, 2 times 9 would be plus 18, x squared. Our next would be 3x. So we have 3x times 4. 3 times 4 would be 12. 12x cubed, because x times x squared would be x cubed. So our 3 times negative 8 would be negative 24. And x times x would be x squared. And 3x times 9, well, 3 times 9 would be 27. And x. Y'all have a good rest of your day. I will finish this and post it later. And the last one we have would be 7 times 4x squared should be plus 28x squared, because 7 times 4 would give us 28, and we still have our x squared. Now 7 times negative 8x, well, 7 times negative 8 would be negative 56x. And lastly, 7 times 9 would be plus 63. See ya. Now at this point here, we would need to combine our like terms. So our 8x to the fourth is by itself. There's no other terms with it. So we'd have 8x to the fourth. And we have minus 16x cubed here. And we have plus 12x cubed. And that's all of our x cubes. Now our x squared, we do have a few more. We have 18x squared minus 24x squared plus 28x squared. And that takes care of all of those. Then we have plus 27x minus 56x plus 63. And this would be all of our terms here. Now, lastly, all we need to do is combine our like terms. Well, negative 16x cubed plus 12x cubed would be negative 4x cubed. Now, this here we do have a few more. So we can combine these in any order, but if we do 18 minus 24 plus 28, it would be get 22x squared. And the last set of like terms that we have is 27x minus 56, which would give us plus, not plus, it would be minus 29x plus 63. And this would be it here. And that's all we have to do for this problem.